did ANOVA with the physiochemical data. And as usual, let us load our packages that we use today. Let us load packages, and let's load library tidyverse. I think we might use it. I'm not sure. Tidyverse. I want us to go back to what we did last time. Let's okay. Let us load the data here. The physiochemical data first. Load data. Let's load the physiochemical data as you always do. Okay. So we said let's put this to be factors. First, second, third, and fourth. Our station, first station, and also the months here. Let's put them into factors. We had May, June, July, August, September, and October. Okay. So let's call it this DF. Okay. So let's copy this. Cancel here. Let us paste it here. Let us run it. And let's view it. There it is. Now, last time we did ANOVA, and this is what we said. Let's put it into a function called ANOV, and an object called ANOV, and we said the function for ANOVA is AOV into what do you want to get? We said we want to know the temperature. Use tilde over the months. You can do also over the stations. I think, I don't know how, let me see the month, how it is written, month. It's small m, month. Okay. So let us attach this data so that we use it appropriately, just without issues. And the first step, we said, first you might want to construct a box plot of temperature and over the months. Let's see, we saw what that gave us. That's the box plot it gave us last time. And so if we run this ANOVA here, and ANOVA, let's see, we did that. Let's do a summary. We said summary of ANOVA. Okay. Now, this was our p-value, and we said that now we reject the null hypothesis and fail to reject the alternate hypothesis because the p-value is less than 0.05. You see, follow the last video, you can see. Now, ANOVA is what you call, in statistics, they are what you call, this the other side, call them parametric and non-parametric statistical test. You know, I hope you understand what parametric and parametric means. So parametric test, ANOVA is a parametric test, meaning that it assumes that the data fulfills some assumptions like an assumption of normality. And to do that, we might test for using a diagram, a histogram, say the normality of temperature. But as you can see, this data I'll show you some other ways of testing for normality, but using, as you can see, this data does not follow a normal distribution, how a normal distribution should be. So this data is not normally distributed. So this data fails the test for normality. And you only do a parametric test like ANOVA when the data is distributed normally. But when the data is not normally distributed, you use an unparametric test, parametric test. Now, the non-parametric test, equivalent to ANOVA, when you cannot do a parametric test that is ANOVA, you do a non-parametric test we call the Kruskal Wallis test. The Kruskal Wallis test. And to do a Kruskal Wallis test, it's just simple as it is. You say Kruskal.test. Actually, once you write Kruskal, it just brings you the rest of the code, the function. So Kruskal.test, just as you did the other time, a Kruskal of temperature against months, over the month. Let's see. As you can see, a Kruskal rank sum test called a Kruskal Wallis rank sum test. As you can see, the p-value is also less than 0.005. Therefore, the months are not the same. So once you cannot do a parametric test of ANOVA, you do an unparametric test called the Kruskal Wallis test. I hope you understand that. So if your data is not normally distributed, you don't do a parametric test, you do an unparametric test, which is for ANOVA is a Kruskal Wallis test. So that's what I forgot to show you last time, and I meant to show you today, that when your data is not normally distributed, use an unparametric test. You can Google and study about parametric and non-parametric tests and assumptions under parametric test, which assumptions are not carried on when you want to do non-parametric tests. Now, that's clarification on the Kruskal Wallis test. Now, let's